Our world is full of beauty, but beneath the surface lies is a reality that defies human explanation. From the darkest unexplored depth of our ocean to the most haunting mysterious hidden in plain sight, Earth holds secrets that science is still trying to unlock. In today's documentary, we're diving deep into one of the most unbelievable places on our planet, a journey that will challenge everything you think. So sit back, clear your mind, and let's uncover the truth together.
Imagine for a moment trekking deep into the rugged, perfectly isolated wilderness of Kazakhstan's snow-capped Tian Shan Mountains. Hidden within this steep, rocky canyon is a geographical paradox, a crystal-clear alpine lake where a massive forest of ancient trees stands perfectly upright, submerged beneath the turquoise water. This high-angle view reveals a stark physical contrast. The treetops emerge as bare wood, while submerged trunks remain perfectly intact and covered in life. This sunken forest survives today because of three specific conditions: a violent earthquake origin, anomalous water chemistry, and extreme deep freeze preservation. The forest's existence relies on an exact sequence of events: a massive seismic shift, specific mineral leaching, and permanent thermal stabilization. To understand how a living forest ended up completely submerged beneath an alpine lake, we have to look back to the year 1911. The entire mountain region was struck by the Kebun earthquake, a magnitude 7.7 tremor that shattered the limestone foundations of the canyon. This cross-section shows the earthquake triggering a colossal landslide. Millions of tons of rock crashed down, plugging the gorge to form a natural dam. Over time, freezing snowmelt backs up behind this barrier, completely drowning the living valley. A grove of shrank spruce trees was trapped alive under a permanent blanket of alpine water. One of the most violent geological disasters in mountain history functioned as the primary engineering event for this underwater landscape. Above the surface, over a century of mountain winds and freezing winter blizzards have battered the exposed trunks into dry, silver wood. This chart visualizes the thermal conditions preserving the wood. At 7,000 feet above sea level, the water temperature rarely exceeds 6 degrees Celsius. This permanent, near-freezing threshold acts as a natural refrigerator, completely halting biological decomposition. In this top-down underwater image, you can see how the wood has adapted. The dead branches have grown a thick layer of glowing green algae that mimics the look of full pine needles. These extreme freezing conditions are the exact reason a drowned forest was converted into a stabilized underwater ecosystem. Looking at this photograph, you immediately notice the vibrant turquoise color of the water, which is driven by the specific geology of the surrounding mountains. This microscopic diagram illustrates the chemistry. Heavy limestone and calcium carbonate deposits continuously leach from the landslide dam, suspending in the pure water. Sunlight hits these mineral particles, triggering an optical scattering effect that turns the water a glowing blue. Because the water is incredibly pure and cold, visibility extends for dozens of feet. Sunbeams pierce through the blue matrix, casting golden light grids across the sunken branches. The aesthetic of the lake is a direct chemical byproduct of the same geological rock slide that initially flooded the canyon. As the seasons shift and the Siberian winters arrive, Lake Kaindy undergoes a final seasonal transformation. In this image of the winter shoreline, you can see the entire surface frozen solid into a thick, textured sheet of white ice. Beneath this frozen ceiling, the sunken forest remains in a state of absolute stillness. The ice locks out all wind and surface movement, leaving the underwater world perfectly preserved. Divers who plunge beneath the ice encounter a landscape of pure silence, where the white ice ceiling above contrasts against the deep green trees below. This winter ice sheet serves as a physical barrier that helps maintain the unique architectural state of the forest. Lake Kaindy demonstrates how a destructive event can create the exact conditions necessary for long-term ecological preservation. It shows how a catastrophic landslide can be the starting point for a stable, century-long underwater environment. What captivates you the most about this location? Is it the fact that a whole forest has been preserved under ice-cold water for over a century, or the physical contrast between the dead spears above and the green trunks below? Let me know your thoughts in the comments. If you enjoyed this deep dive into Earth's geography, please hit that like button, subscribe to the channel, and turn on the notification bell. Stay curious. The world's most unique geographical anomalies are often found where sudden ruin and permanent preservation intersect.